Hi, welcome back to the second part of Addition 2. So earlier we looked at number bonds to make numbers up to 10. So finding numbers that combine together to make 5, 6, 7, 8, 9 and 10. Had some more work in from children who've been working on yesterday's work on finding one more and using the part whole model. So big shout out goes to Ben. He did some brilliant part whole models looking at different things, different ways to sort his family. He used eye colour as one of those. Keep sending your things in to me. If you want to share any on Twitter, tweet with hashtag MathsMasters or Marvellous Maths Masters and we can share those and I can look at all your different approaches. That's brilliant, thank you for those. So earlier I was showing you a card game that you could use to find number bonds to 10. So now I've got a pack of cards. Take out the jacks, queens and kings and put those aside and then shuffle the deck of cards, and then what you do is you lay the cards out in a nice set of 4 rows of 3 cards. A nice little array going on here for when we get to multiplication, and look for number bonds that make 10. So 2 and 8 add together is equal to 10. 5 and 5 adds together, that's equal to 10. And put some more cards in the spaces and go again. 9 and 1 goes together, adds together, is equal to 10. It makes 10 when it's combined together. 7 and 3, and keep going until you get rid of all your cards. And try and improve your speed at that, so go quicker and quicker. So we were looking at finding fact families, and you can use the tens frame to help you to find fact families. You can chop the tens frame up. You can use, so we had our tens frame chopped up like this. So it's now a 5 frame, so we can use that to find fact families. You can use the part whole model, you can use cubes, counters, anything that you want to use to help you. So to find all the fact families of the number bonds that go together, they combine together to make 5, you can use counters on here. Okay, 2 and well, let's actually start off and we'll work systematically. So we can have 5 and 0 is equal to 5. So 0 and 5 is equal to 5. We can have 4 and 1. I changed my mind. I was going to take that one, but then it would have been 1 and 4. And I thought I want to start writing here first, so I'm going to make it 4 and 1. So we've got 4 and 1 together combined is equal to 5, and we add those together. And we can look at it that way. We've got 1 and 4 makes 5. So we're going to take this one off again because I want to work systematically. I want to drop down 1 each time. So I make sure I've got all the different number pairs. So we can have 3 and 2, that makes 5. And can we look at it this way? We've got 2 blue counters and 3 green counters, that makes 5. I'm going to take this one away. So now we've got 2 green counters and 3 blue counters makes 5, and 3 and 2 makes 5 as well. So that is the number sentence we've already got. So we know we've exhausted all the possibilities for our number sentences. So we don't need to go any further with those because we're starting to repeat them. So we found 6 possible number sentences. Which is the part, which is the whole? Well, these that add together are the parts that combine to make the whole. And often, always the equal to sign, symbol, shows us where the whole is. But does it always need to go at the end of the sentence? So if we were using this as a part whole model, 5 So we could have 5 and 0 makes 5. It doesn't always have to go at this side. It doesn't always have to be 5 and 0 is equal to 5, makes 5. We can have it the other way around, so we can have 5 is equal to 5 and 0. And we can have 5 is equal to 0 and 5. So these are addition fact families, and for every number there are 4 of them. So we can have 0 and 5 equals 5, and 5 and 0 equals 5. So there are 4 fact families. We can do the same with other numbers. So let's have a see if you can have a go at finding the fact families. So if we change this and we use the number 7, can you find the fact families for us to have? We'll have 2 and we'll have 5. So 2 and 5. So what I'd like to do is find the 4 fact families, the addition fact families that make the number 7. So the first one might be 2 and 5. 2 add 5 is equal to 7. Can you find the other 3 fact families to make that fact family, to find the other 3 number sentences, to make the fact family to make the number 7? So just pause it and have a go. Okay, so hopefully 2 and 5 you've got make 7. We can do it the other way around. 5 and 2 is equal to 7. And we can start off with the total. We've got 7 altogether. 7 is equal to 5 and 2. And 7 is equal to 2 and 5. We can also use that to find missing parts as well. And it can help us to do missing number sentences. So, if we've got 6 is the whole, and 5 and 1 is the part, we can make missing number sentences. 1 and something is equal to 6. Something and 1 is equal to 6. 6 is equal to, it's the same as something and 1. And 6 is equal to something and something. So can you pause the video and have a go at those? Okay, so hopefully you found 1 and 5 goes together to make 6. 5 and 1 goes together, adds together, and it's equal to 6. 6 is equal to the parts 5 and 1, and the whole 6 is equal to the parts 1 and 5. So we've got the 4 fact families, the 4 facts that make that fact family there. The other thing we looked at in the first session today is number bonds that go together to make 10. So you've got the card game that you can play. There's lots of things you can do to make 10. So 7 and 3 is equal to 10. We can again turn that around and have 3 and 7 is equal to 10. Now if you want to check this, you can use your tens frame to do this. Use counters on the tens frame to find the different numbers that go together to make 10. We can have 10 is equal to 7 and 3. And 10 is equal to 3 and 7. Those are all the number bonds using those numbers that go together to make 10. Now can you have a go? What I'd like to do is find all the number sentences, the number bonds that go together to make 10 using the numbers 4, 6 and 10. So the first one might be 10 is equal to 4 and 6. Can you write the other 3 number sentences to make that fact family? So hopefully now you've got 10 is the whole and the parts of 4 and 6 that make 10. So now you can have 10 is equal to 6 and 4. It's made up of the parts 6 and 4. 6 and add 4 is equal to 10, and 4 and 6 is equal to 10. And those are the fact families for that as well. Now, a little problem for you to solve about the fact families. So, looking at using number bonds of 10, we have a little problem for you. So, Ellie has, question is, can these be done in any order? Can we do them in any order? Does it matter? Our four facts for our fact family, does it matter what order they're in? So have a think about it here. Ellie has 3 number cards, 4, 6 and 10. She makes number sentences, so she's trying to make number bonds to go together to make 10. She's written 2 number sentences. She's put the cards together. She said 4 and 10 is equal to 6, and she said 4 is equal to 10 and 6. Explain what Ellie has done wrong. Try and use the words part and whole in your explanation when you explain it. So explain it for our maths mo. What has Ellie done wrong? Correct her number sentences and complete the fact families, the correct fact families for those 3 number cards. Okay, so hopefully you've had a think about this. What has Ellie done wrong? Well, she has got the whole in her addition here. So she's using the whole here as a part. So she's saying, if we draw 10 is the whole, and it's made up of 2 parts here, 4 and 6. But she's adding 4 and the whole together. So she's adding the part and the whole together, which actually gives you 14. So it's incorrect. Again, she's making the same mistake here. She's mixing up the whole and the part. Here, this is a part, and the total that you get when you combine them together is the whole. So the whole should be 10, not 4, because 4 is a part of the whole. So we've got a part, and there's the other part. They should go together to make 10. So to correct her number sentences, she could have 10 is equal to 4 and 6, 10 is equal to 6 and 4, 6 and 4 is equal to 10, and 4 and 6 is equal to 10 as well. Okay, next problem. Okay, have the washing out on the washing line, and some of the buttons have blown off. And so how many different ways can they be sewn back onto these 2 shirts? How many buttons are there? There are 1, 2, 3, 4, 5, 6, 7, 8, 9 buttons. And I'd like you to think of all the different possible ways that you can sew the buttons onto the 2 shirts. So you're going to have to find 9 is the whole. You're going to have to think of how many different ways you can part them, break them into 2 parts. And we call that partitioning, where we can break the number into different parts. Okay, so how can we do this? Pause the video and have a go. Try and work systematically. Okay, so I'm hoping that you came up with some different ways of sewing the buttons back onto the 2 shirts and thinking of ways of working systematically. So what we can do is start with nine buttons we had. That's the whole. And what can we have as the 2 parts for the 2 shirts? So 9 add 0 would make 9. So one could have 9, one could have 0. We could have 8 and 1 equals 9. 7 and 1 equals 9. Now normally I'll put the 0 and 9 at the other side, so do the number sentence the opposite way around. But I'm just going to work down 6. Oh, I've made a mistake. 7 and 1 doesn't make 9, does it? 7 and 1 makes 2. 6 and 3 makes 9. 5 and 4 adds together to make 9. 4 and 4 is equal 4 and 5 is equal to 9. And now I can see that I'm doing the other way round. So the next one, 3 and 6 is equal to 9. This the opposite way round, 2 and 7 is equal to 9. 1 and 8 is equal to 9. And 0 and 9 is equal to 9. Can you see a pattern there in the numbers? Here it's going down 1 each time, and here it's going up 1. It's increasing by 1 each time. Okay, so those are all the different possibilities. There's different games you can play. If I show you 5 fingers, how many have I got hidden? 5 and 5 number bonds to make 10. If I show 3 fingers, how many fingers are hidden? So there's going to be 7 hidden, because 7 and 3 combine to make 10. Another way of doing it, you can have some pots. If there are 8 counters in this pot, how many are going to be in this pot? So if there's 8 in there, 8 add 2 makes 10, so we've got 8 and 2. Another way of doing it is to count, listen to the counters dropping into the pot. How many did you hear dropping into the pot? How many more would you need to add to that to make 10? What did you get? Should have been 6, because there was 4 dropping into the pot, so 4 and 6 makes 10. In the activities section, there's some practice work you can do at looking at finding number bonds and some problem solving using number bonds. Share those with me. Remember, hashtag Marvellous Maths Masters, hashtag Maths Masters. Share those with me. I'd love to see the different work that you've been doing, and I'll be back here tomorrow for the 3rd edition session. Goodbye.